first step in math induction is to show true for n equals 1, and to do that, substitute n for 1 and solve. The second step is to assume true for n equals k. When doing this, remember to write out the entire series and then substitute for n equals k. The third step is to prove true for n equals k plus 1. To do that, write out the original series and add the next term by substituting k for k plus 1. In this example, this is shown by the expression 5 minus k plus 1 equals half times k plus 1 times 9 minus k plus 1. Notice how k plus 1 is only used for the following term. This is because k plus 1 represents the next term in this series. Next, replace the original expression with the equation it was set equal to. Therefore, 4 plus 3 plus 2 plus 5 minus k is replaced by half times k times 9 minus k. Then factor and simplify the left equation to match the other side of the equal sign. To do that, I first distributed the half k to 9 minus k and then distributed the negative to k plus 1 in the expression 5 minus k plus 1 and simplified. This resulted in 9k minus k squared divided by 2 plus 4 minus k. Then to add 9k minus k squared divided by 2 and 4 minus k, I multiplied the numerator and denominator of 4 minus k by 2, which equals 8 minus 2k divided by 2. Next, I added the expressions 9k minus k squared divided by 2 and 8 minus 2k divided by 2 by adding the numerators to equal 9k minus k squared plus 8 minus 2k and divided the whole expression by 2. Once I simplified the expression, I got negative k squared plus 7k plus 8 divided by 2. This is now a polynomial that can be factored, and this equals k plus 1 times 8 minus k divided by 2, or half k times k plus 1 times 8 minus k. Now, since this expression does not look like the right side of the equal sign, you can simplify the right side to equal half times k plus 1 times 8 minus k. Both sides are now equal, therefore proving the series true.
So for this example, our first step is to prove that it works for n equals 1. To do that, we will plug 1 into the expression 1 over n times n plus 1, and that will simplify into 1 half. On the other side, we will also plug in 1 into the expression n over n plus 1, which also simplifies into 1 half. Therefore, the series does work for n equals 1. The second step is to assume the series works for n equals k. To show this, substitute all the n's in the series with k's. The third step is to prove that the series works when n equals k plus 1. To show this, rewrite the series from step 2, but add the term 1 over k plus 1 times k plus 1 plus 1 on the left side. On the right side, the expression will become k plus 1 over k plus 1 plus 1. Next, substitute the expression 1 over 1 times 2 up to 1 over k times k plus 1 with k over k plus 1, which is our assumption from step 2. So after simplifying a little, we have the expression k over k plus 1 plus 1 over k plus 1 times k plus 2 equals k plus 1 over k plus 2. Next, we will try to get the expression on the left side to have a common denominator by multiplying k over k plus 1 with k plus 2 over k plus 2. After distributing and simplifying, we get the expression on the left to become k squared plus 2k plus 1 over k plus 1 times k plus 2. The numerator k squared plus 2k plus 1 will factor into k plus 1 times k plus 1. So one of the k plus 1s in the numerator will cancel with the k plus 1 in the denominator. Now the expression on the left is just k plus 1 over k plus 2. This matches the expression on the right, which signals that we have successfully proven this arithmetic series. For our first step, we will need to show that the series works for n equals 1. So we will plug in a 1 for all the n's. Both sides will simplify to 1 in this problem, so we have shown that n equals 1 works. The second step is to assume that n equals k is true. So to do that, we will substitute all the n's in the series with k's. The third step is to show that n equals k plus 1 is true by plugging in k plus 1 for all the k's. Then replace the series from 1 to k with k times k plus 1 over 2, which is the assumption from step 2. So after simplifying the right side and the left side a little, we get the expression k times k plus 1 over 2 plus k plus 1 equals k plus 1 times k plus 2 divided by 2. Next, we'll have to get the left side to have a common denominator by multiplying k plus 1 by 2 over 2. After distributing everything out in the numerator, the simplified expression becomes k squared plus 3k plus 2 over 2 equals k plus 1 times k plus 2 over 2. The numerator k squared plus 3k plus 2 factors into k plus 1 times k plus 2. Now the expression on the left side matches the right side, so we have successfully proven this arithmetic series.